let's say having this, we ask a related question. What if I still have these charges at 40 degrees, but put the first one at the 10 degree position and the last one at the 170 degree position? In other words, both of these charges at 10 degrees from the axis, and then the remaining 160 degrees divided into 4 segments with 3 charges. Okay, same charges we have here. I'm not going to bother to label them. Well, if we already have this information, we could use it to find this. Okay, yeah, we have to do a little bit of work, but not as much as if we had to start over down here. Now, we've already got all these components, so let's just say, okay, well, if the charges were here, 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 and here, so these are the 5 charges, we can calculate the net field very easily. Having calculated that net field, we could find the magnitude. We could also find the direction of the field. Having done so, we can then simply rotate that field 10 degrees, and we get the field due to this configuration. So let's see, what's the sum of these fields here? Okay, calculating electric field, just adding up the components, I get negative 1.9, negative 5.2. So here's the electric field. I find that if I resolve these, I get something that's approximately, actually, I think more like 5.6. I'm doing honest mental calculations here, so check me out, I could be wrong. About 5.6, and I get this at about 170 degrees. Let me check that. Actually, I think I'm getting 160 when I do this. I thought I'd nailed it. When I calculated the 5.6, I just used the Pythagorean theorem for 5 and 2. Found out that that would give me a magnitude of about 5.4, about 0.4 bigger than this. So this is about 0.4 bigger than this. And 1.9 there is about 1/3, very close to 1/3 of 5.6. 1/3 of a radian is about 20 degrees. So this should be 20 degrees off of the positive y-axis, which would put this at 160 degrees. However, I know that it has to be 170 degrees, so this gets real interesting. It has to be 170 degrees because everything is symmetric about this direction. If we go from here to here, we got 40 and 80 degrees. From here to here, we got 40 and 80 degrees, so that these vectors are symmetric with respect to this direction. Not sure just how that's going to reconcile. However, we'll go on. Okay, I couldn't let it go. I had to ponder it. 1.9 here should have been a 0.9. I just added up carelessly, which would make the magnitude of this more like 5.3. So this is going to get messed up. Should be about 5.3. And 0.9 is about 1/6 of 5.3. 1/6 of 57 degrees is pretty close to 10 degrees. So the 170 works a lot better. And the 170 is what it has to be. I wasn't fudging that. That's what I honestly got when I made another mistake. Okay, it has to be 170 because this vector has to be parallel to this vector. Let me fix that off camera. Okay, now the vector we get over here, we get, if we just rotate this picture 10 degrees, this vector rotate 10 degrees down to the 180 degree position. We're not sure from these calculations that it's going to actually, this is going to be exactly 170 degrees. Matter of fact, any rounding we do here is going to give us something that isn't exactly 170 degrees. But the symmetry argument tells us that it is. So that with the 10 degree rotation, we get the vector here. It has magnitude approximately 5.3 at 180 degrees. It's real clear from this picture that you do have a symmetry about this direction, so that you do have exactly the 180 degree angle, whether your calculations show that or not.